All right, I'm back. And I'm going to be going through some of our older assignments that you got to do while I was gone. And that way you can make up some of your work over the next week because we're going to be moving on eventually here. But I want to give you a chance to catch up anything that you need to. So this is this assignment, Unit 8, Lesson 1, Activity Sheet 1. This is what it looks like. It's just one page, and it's got 3 parts to it. There is a little section in the Agile Mind. I might as well show you what it looks like. All right, courses, Algebra 1. Remember, you can always log in. There's a previous video that we've had. It's like the 3rd or 4th from the top, and it says how to log in. You can log into here. If you need help, let me know. But we're at Section 8 now. I've made videos for everything up to Section 5. We skipped 6 and 7 because they're kind of not perfectly within the realm of algebra. And we're in the overview. We're talking about a dune buggy rental company, and they charge you $30 basically, $29.95 plus 16 cents per mile. You're on a budget for your vacation. You need to make sure you don't spend more than $75 for the rental fee, and they're going to ask how much. Now, this is something you can solve just by kind of, most of us would probably say, okay, so I'm going to pay $29.95, subtract that from 75, and then I can divide the rest by 16 cents and figure out how many 16 cents it takes to get up to my limit, and you can figure out how many miles you can drive and stuff like that, because we're gonna try to figure that out. However, right now we are trying to set up equations, okay, which is why this is called linear equations and inequalities. So we're going to think about it a different way. Okay, so I'm going to go down here and I'm going to, let's see what they've got to say. 29.95 per mile plus 16 cents. They're going to change rental charge to an R. And then they're going to, we'll talk about what this is doing here. Okay, so what's going to happen is we're going to take this information and we're going to turn it into a formula, an equation because it has an equal sign. It's a linear equation because it has 2 variables like x and y. Remember, this would be y equals mx plus b, just backwards. Okay, so this is standard form. Not standard, this is y-intercept form, slope-intercept. You can find out all of that stuff from here. It's something we've done before, okay? So if you recognize that, it goes a lot quicker. But here's the cool thing. The whole point of setting this up, as we talked about before, is, yeah, since it's just one situation, probably the fastest thing to do would be to subtract 29.95 from 75 and then divide by 16 cents, 0.16, and it would work. It would tell you how much the answer is. However, we're trying to set this up because what if you want to be able to figure out different amounts? Okay, so the function tells me any possible thing. So what if I drive 50 miles? What if I drive 75, 100 miles, 200 miles? I can figure out any of those, and they're right here on the graph. So if I look, if I drive no miles, it costs about $29.95. However, if I drive 50 miles, it costs, just under $40. If I drive 200 miles, it costs just a little more than $60. I can figure that out from the graph. And that's why we learn how to make graphs. They're useful. They're useful for keeping track of information. Now we're going to have some extra credit assignment with more graphing, and that makes it even more useful if you have a lot of information. So notice they've got, hey, look at that. If I drive 152 miles, it costs $54.27. This formula tells me any price based on how many miles I drive. 16 cents for every mile plus the $29.95 charge just to rent. So this right here is telling us the answers. I think that we're going to solve it now on our actual assignment. Okay. So what we're going to do is, if we have $75, we can use this formula. We can say, well, let's make the amount we pay be $75. The only thing missing now is the miles. So that's what we're going to do here. Okay, so a dune buggy rental company, charges $29.85 plus 16 cents per mile for each mile driven. The cost in dollars of renting a dune buggy are, that's the cost. Cost is R. Oops, I'm going to make this whole thing slightly bigger than that. That's better. I can zoom in a tiny bit too. Where'd you go? Plus, plus, plus. There you are. There. Okay. We also know that miles is M. So if I want to make this work, well, I'm gonna start out with the cost. The cost is, well, I get charged $29.95 plus 16 cents. Because we're going to do it 16 cents every mile. So the way we can do this is when we're saying for every, we're saying, let's see, if I have $1 for every candy bar I buy, and I buy 5 candy bars, that's $5. Whatever the price is, I just multiply it by how many I buy. So same thing here. If I drive 1 mile, it costs 16 cents. If I drive 2 miles, it costs 32 cents. If I drive 3 miles, and so on and so forth. So what I have to do is, all I do is do 16 cents times M. Because now if I drive 10 miles, I multiply 10 times 16, and it costs $1.60, which is 10 times 16. 16 cents 10 times. So all I have to do is use multiplication to figure that part out. I'm going to write it slightly differently though. R equals 0.16M plus 29.95. The reason I'm doing that is this is, just for the record, y equals mx plus b. That's something we did before. That's from an earlier section in the book. And it's something that never ever goes away. It's a very useful thing to remember. Y equals mx plus b. M is the slope. B is the y-intercept. Okay, so then if I was graphing, I could graph it very quickly. Okay. Okay, one other way you could do it, just for the record, you could do R, we could do something like R of M, R of M equals 0.16M plus 29. You don't have to do that, but you remember we can also do formulas that are like this, and then it tells me how many miles I drove and will tell me how much it costs right there. Okay, so now they want us to use this rule. We're going to reuse this guy. We're going to use this guy. We're going to say, what about, we're going to rewrite it, use the rule to write a mathematical statement that indicates how much you spend exactly. If you spend exactly $75, how far you can go, whatever. Okay, so we're still going to use this. I'm going to copy and paste it. Where'd you go? There it is. Okay. So this is the formula. It tells me based on how many miles I drive, how much it costs, right? And we're saying I have to spend $75. Now, this is the way this usually works. This is the way these always work. Up here, we have a formula. All I can do with that is graph. I can't tell you how many miles I can go because I don't know how much it costs. And I can't tell you how much it costs because I don't know how many miles I'm going. They depend on each other. Remember, that's why this is called a dependent variable. It depends. So until they tell me something like $75, I have $75, now I have some information to plug into there. Until I have that information, it's useless. Well, it's cool because I can figure out things and I can make a graph like they were showing up here. But I just need to have a little information on one thing to find out the other. So right now, I know that it costs $75. Remember, we said R was the cost, the rental cost. That's why it's R for the record. So I'm going to turn R to 75 because That's how much I'm paying. And 0.16 and M, none of this changes. The formula is still the same formula. All I did was plug in the information I have. And that's all you have to do here. Okay, so we got this. Oh, Control C. That is way too big. There's that. There's that. We're almost done with the assignment. Use your rule to write a mathematical statement that indicates you cannot spend more than 75 cents. 75 cents. Okay. So right now, we're not even figuring out the answer. We can, though, because it doesn't tell us not to. So we're talking about equations versus inequalities here. But that's the difference between 2 and 3. We'll talk about that in a moment, but let's figure this out. We might as well. So remember what I said you would probably do. You'd take away $29 from the 75 to find out how much money you have to spend on miles and something like that. Well, that's exactly what happens when we solve it here. It basically forces you to do what you would have done a few years back in middle school to figure this out. Okay, so the math never changes. It's just the way we write it that changes. So we have $75 equals 0.16 M plus $29.95. I want to figure out how much that costs. Okay, well, I have everything. Well, I know it costs $75. I just want to know how many miles I can drive. Maybe I get to 40 miles and I'm like, oh shoot, I've got to turn around and go back before I stay out here too long and I waste money that I don't have to spend. Okay, so the first thing I would do, just like I said, is I would take away $29.95 from 75. Here's what it looks like in algebra. I take $29.95 from the left side. And $29.95 from the right side. This is what most of you would do. You'd say, okay, so I got $75. I spend $29.95 to figure out how much just to rent it. And oh shoot, I don't have any calculator with me. I go, well, that's 30, right? This is basically 30. If I take away 30 from 75, I get 45. Because 30 plus 45, but then I didn't really spend 30. I spent 5 cents less than that. So really, I should have let's see. I'm having a moment. 45.05. Absolutely sure that's right. Because I didn't really spend a full 30. And I've got to divide by 0.16 anyway. Here we are. So calculator on my phone. Yes, I use a calculator sometimes too. 5 minus 29.95. Yeah, I did it right. Good job. So I spend $29.95 to get this car, this dune buggy. And what I'm left with is $45.05 to spend on gas, or to spend on how far I drive it. So now I'm going to figure out, so I have $45, just over $45 to spend on the driving part. And it costs 16 cents per mile. So now I'm going to divide that by 0.16. So what that looks like is divided by 0.16. You know what? I'm just going to write it in like I used to because it looks better. In algebra, and I'm going to be a stickler for this, writing things down correctly is very important. It's like learning how to be organized. That's what it really is. And so try your best to actually write out the steps. That's something I will insist on, okay? In all assignments, it's very important that you write out the steps. Now, you might be able to do it a lot faster with your what do they call those? Your little computer pencil stylus. There we are. So I'm dividing everything by 0.16. Let's see what that does. So I'm basically saying I have $45.05, and I get a mile for every 16 cents that I can spend. So how many miles can I go? I'm dividing by 0.16 to find that out. Divided by 0.16. I did that wrong because computers equals divided by 0.16. It says I can drive about 281 miles and 50.56. So 281 miles. 281.56 miles equals the number of miles I can drive. So what's happened up here is this is what we usually do. We cross this out. We cross these out. And you subtract it to get rid of one side, and you divide it to get rid of the other. But it's really just math that we usually do. So what are we saying? We can drive 281 miles. 0.56 miles. Why not? Right? Okay. The good news is the next step is just like this. The only difference, look, it says use a rule to write a mathematical statement that indicates you can expend exactly $75 per day in rentals. This one says cannot spend more than. That's a different, because this one we're saying this is how many miles he's going to drive, but really the implication is in real life we're not really saying you need to drive this many miles. No, we're just saying you don't have to, you can't drive more than that. So if he went 200 miles, good for him. He just didn't spend all of his $75, right? Because he didn't drive far enough to spend it all. And that's really what's going on. So when we want to say something is equal to, we write equals. In math, however, if we want to say, oh, you don't have to be equal to it, you can spend a little less, that'd be no problem. That's when we use inequalities. So this is an equation. This is an equation. That's an equal sign. Whereas what we're about to do, the good news is, when you're dealing with inequalities, everything is the same basically. The only difference is we don't want to spend $75. We can spend up to $75. That's the big difference. All right, everything in the math works exactly the same. That's the cool thing about this. You're not going to have an issue where it's like, oh shoot, I have to change how it's all done. No, not really. All we're saying is instead of them being equal, instead of the amount that I spend being equal to 75, now I'm saying the amount I spend, oops, I made all of these point the wrong way. The amount I spend has to be less than 75. Remember, when you're typing in inequalities, it points at the smaller number. So notice the amount I spend, the $75, is a bigger number than what I'm going to spend. I want the number of miles that I drive to be less than 75. So the amount that all the stuff that I do to, when I crunch the numbers, I want it to be less than $75. So I make everything say that. Instead of equal, I have it be less an inequality. So inequalities have this or this. There's one other thing that I should do, just to be completely clear. This is technically still not right, because what this is saying is I can't spend 75. I have to spend less than 75. But what's being set up here says cannot spend more than 75. Does that include 75? Yeah, you can spend 75. You just can't spend any more than that. So inequalities are very specific, very special things. So we have to be very specific about that, whether it includes that number or not. In this particular one, yeah, we can spend $75. So right now we're saying it's less than 75. But we want to say it's less than 75 or equal to 75. So that's why we put this little dash right here. like so. You know what? I'm going to do it like Control Z, Control Z. I'm going to go like this. I'm going to go like this. Why they all look the same. Control C, Control V. Now I'll just put them all in. Control E. You just love my mad computer skills. I'm just amazing at it. And yeah, the whole point of having a line like this is that's half of an equal sign. As we can see, be greater than or equal. So what we're saying is $75 is greater than or equal to what I'll spend. And the math works exactly the same. I'll talk you through it real fast, but we're basically done. There. I wish that I could give you these symbols. There's probably a way to do it. Okay, so that's everything. Just remember, so instead of saying, hey, let's make this be equal to the amount of miles I drive should equal $75. We're just saying the amount of miles I drive can't be more than $75. It could be 35 or 25, anything less than or equal to 75. And so over here, the work still works out the same. Basically, I just need to figure out the first part, when it equals 75, right? So it still works out to being 281.56 miles, just like up here, just like we did up here. I subtract the $75, the $29.95 to rent the dune buggy, and then I divide by 16 to figure out how many miles are left. And then the only difference is throughout, from the beginning to end, I'm saying, well, actually, I don't want it to equal this. I'm not saying I have to drive 281.56 miles. I'm saying I can drive less than that or equal to that, and I won't spend more than $75 that way. So I could drive 280. M could be a number less than it could be 280 or 260 or any number less than this, so that I'm driving a number of miles that doesn't cost more than $75. And that's all that's going on. So it's just another way to write things to be more realistic, because in real life, that's the way we think about it. When you really think about it, that makes more sense than using an equal sign. That's why we invented the inequality. Thank you for coming to my TED Talk. I look forward to seeing you in class. Good luck with this assignment if you haven't done it. Goodbye and good luck.